Hello ladies and gentlemen, welcome back to the lab, and today we got a suggestion from a subscriber. Can we test the output of this thing and this thing under load? So let's get right into the video. Now I thought it would be actually fun to film how I connect everything, so there you go. So essentially we are connecting the AC output from the transformer here we have on the bottom to the rectifier. So that's pretty straightforward. Black and white wires carry AC, and that AC comes to the rectifier. The rectifier will rectify the AC and give us DC. Now the rectifier has its own voltmeter, does not have an amp meter, so we won't really be able to see output amps in DC. But we will be able to measure amps in AC, because we have a AC amp meter on this transformer on the bottom, and I will have a clamp meter for us to see the output. So that should be pretty decent. In terms of load, I am using a 10 ohm nichrome wire resistor. So technically this gives us about 70 volts, so we should be able to see around 7 or 8 amps, I believe. So we just hook it up and see how it will perform. Now, you really need a good meter to measure your AC amperage or even DC amperage. So we don't have a good meter, we have an okay meter, so we will have some percentage of error, but it should be more than enough for the purpose of this demonstration. By now, if you hadn't figured it out, there are videos in cards for you to click on, and it will prompt you to the videos where I make this power supply and this rectifier. So a couple parts of the power supply and then 2 parts of the rectifier. Really cool, really easy things to make. It seems like a lot of people want to have an AC power supply, and that is totally understandable. It's really powerful for what it is, and you can have AC and DC if you want to, but you need good rectifier. So that's why I have this rectifier right here. So what are we doing? We will turn it on, and as you see, it makes a humming sound, and we can see the coil glows red hot, and we have a little bit over what is it, something like 60 volts right now, 57 volts. I will actually check it. I think it's 57. So let's see. No cutting, no editing in this part, so I will check the voltage on, well, while I actually film. Let's see. I think it's 57. 59.6. Okay. Well, that was close. 59.6. So we have 60 volts DC, and we have a lot of heat rising up here. A lot of heat. It's even hard to hold my hand. Now just another shot of it. As you can see, it's hard to hold my hand on top. It's very, very hot. And you know, if you don't believe me, you know, like, oh, it's not hot. It's not hot. This power supply can't supply that much power. There's a paper towel I just rolled up, and look. You see? Caught fire. Caught fire, you see? So I have the power supply off right now, and you clearly saw we had a almost 10 amp according to this meter load. Now, you know, it would be bad if I didn't have another amp meter for you to show. So there we go, Mastercraft amp meter right here, and I'm going to clamp on this guy, and we have 8.3 amps, 8.3 amps, you'll call it that. So we have 8.3 amps at 60 volts. DC, well, we have DC and AC amps are different, so that you have to remember. But now I will measure AC voltage that is coming out from here, and let's see what it is. So as you can see, we clearly have 50.8 volts, and we are outputting more volts in DC. We have 60 volts, so we have a 10 volt increase over the rectifier, because AC and DC power is different. You calculate it differently. There's a magic number involved, which is usually what is it? It's not 40%, but it's something like that. I'm pretty sure that there would be people that will be able to tell me how to calculate it in the comments down below. I would really appreciate it, because you can't really find it in the internet. I am quite disappointed. You can't find an easy way to calculate it on the internet, so that doesn't quite make sense. So let's actually connect the oscilloscope and see what is going on. Let me have a load. Ha! I figured it out. The problem is very, very simple. The stupidity, okay? The stupidity went through the roof. You put a freaking giant electromagnet by this very sensitive device, and no wonder you're getting freaking 60 volt 60 hertz freaking wave on your screen. What are you expecting? I have no idea. That is absolutely stupid what I have done. Now problem had been fixed, you know, so very good, very good. So essentially I have the scope set up, and excuse me for the sound, somebody decided to cut the grass. Okay, they're gone. Anyway, so what is happening on the scope? We have 0 line right there, and we have the whole 8 divisions up, 10 volts per division, 10x on the probe, 1 volt per division here, 10 volts per division, 80 volt resolution. Okay, and we are set at 2 microseconds per division. Okay, and hopefully that will help you to see the signal. And somebody's cutting the grass again. So I am turning on the PSU, and as you can see, we have this waveform, which you can actually see now. The coil is glowing red hot, and that is all. Good, you say. Okay, well, you see now we actually do the measurements, and we will see that I want the min and the max. Okay, I want the min and the max for our thing. So we'll move that over. and you will see that we have 1, 2, 3. So 3 times by 2, that is 6. So guys, right now I did something different. So I hooked up more nichrome wire, and we have 4 amps less according to my meters. So we are running at 4.3 amps, and it's actually not bad. We are getting the same type of ripple, but now we have increased the voltage furthermore. So as you can see, we still have the same ground line right there. So that is 0 volts. Each division is 10 volts. So that is 1, 2, 3, 4, 5, 6. And as you can see, we have more than 60 volts. So let me actually move, oh, wrong knob. So we have about 60, I'd say 65 volts DC coming out, and that would be, we'll see on the meter if I would actually show to you. And the top of the ripple is actually about, so that is 1, 2, 3 and a little bit, that's about 67 volts. So we have 67 volts, and we have 60 actually no, that will be like a 3.5. So 3.5, so 63.5 and 67, so that's a 3.5 volt ripple on our output. That is not bad considering the load. So as you see, we don't have we have a certain region where we can draw a lot of amps and still be able to have that output. Now you will say, how far can you actually take this? And I can take it pretty far. Let me show you. Okay guys, so I did something really stupid and something really crazy. So it's very unrealistic I will ever use that much of power. But let's be realistic, anything can happen. So I have a 1.5 or actually even 2 millimeter nichrome wire from a dryer. Okay, dryer. You know, it's really thick wire, and pretty much, you know, we are pulling more than this meter can show. You know, I measured it, it's 28 amps what we are pulling. Now is it true? We're about to find out, but I'm just going to spread it out so we can do longer tests, because it will heat up really fast, and that is not good for us. So pretty much I am ready. Mother on speed dial, and we have it hooked up. So I will just show you the amperage right here. 20 26 amps. Is the meter actually going more? Yeah, it's going over its range. Oh my goodness. Well, what's the voltage? I want to see the voltage. Okay, we're almost at 45 volts. 45 volts at 30 amps. That's almost 1500 watts. I would say 1300 watts. That's a lot. That's a lot. I really don't want to see the ripple on this thing. You know, even though we have a lot of capacitance there, we have something like 8,000 microfarads of capacitance in this thing. It still can't it still can't sustain that current. That is absolutely insane. And yeah, like the breaker still works. Let me touch the transformer. I don't want to touch anything live, but you know, the input. I'm touching the 120-volt coil. It's a little bit warm, and the output is a little bit warm. Nothing crazy. Nothing, you know, something that would catch fire. Not happening here. So this is the oscilloscope, and as always we are 1 volt per division, 10x on the probe, so 10 volts per division, and we are at well, for some reason I have to adjust it all the time, so this is a 0.0 volts. So we clearly saw that we have about 45 volts on that meter right there, and on the rectifier. So let's actually see what we are getting on the scope. And by experimenting with it, we figured out that it's the bottom portion of the ripple that we're getting is the voltage that that meter is reading. So we should see the 45 volts here, and I will actually predict that it will be the ripple will be just above this center line, because it's 4 divisions, and we'll be about halfway. So let's actually turn it on and see. And well, no, that is different. But actually, well, I can't really have it on for a long time, but you can see that we have about 50 what is it, 54 volts, so that is really close. Now that is more than enough footage for this video already, and I don't really want to film anything more, but let's make a go. If you guys want to see even more ridiculous load of this thing on this power supply, we can make that happen. All we have to do is like the video and subscribe, you know, as always welcomed. And yeah, then we'll figure something out. You know, if you guys want to see 2000 watt load on this thing, we can make it happen. Or, you know, we can make anything happen. So yeah, that would be really cool. As always, there will be a couple of videos on your screen for you to see. So guys, that's about it for this video. You all know what to do. Like it if you like it, dislike it if you dislike it, and don't forget to subscribe to my channel if you hadn't subscribed already. And yeah, you're going to see some of my other videos on your screen. I really hope you click on some of them, and you'll make me the happiest person ever. And yeah, as always, see you in the next video.